Hi, welcome back to the Math and Science. In today's lesson, we'll use this example to further understand how to work with Kirchhoff's laws. The network might look a little bit complicated. We will break them down into simple loops. I will simplify it as much as possible. That said, let's get into class. Now, here's our example. The first thing I want us to do is to label or to identify the current paths in this network. Now, if you look at this junction, this is a node A. At node A, I should have my current I flowing from voltage source E. Now this I will travel to node A. At node A, I expect this to split into I1, and here also I will have I2. Now I1 will continue at node B, and at node B, expectedly I1 should split into I3. Now I should have I3 here. Probably you want to label this I4, but I prefer to label this as I1 to reduce my complexity minus I3. Remember from the current law, as this node, the current leaving this node is equal to the sum of the current leaving the node is equal to the sum of the current entering the node. Entering the node, we only have I1, but leaving the node, we have I3 and I1 minus I3. At node C, we have I2 flowing into node C, I3 flowing into node C, and we have another current leaving node C. So from our current law, we know that the current leaving node C will be the same thing as I2 plus I3. Now at node D, we have I1 minus I3 flowing into this node D, and also we have I2 plus I3 flowing to node D. We have current leaving this node. So the current leaving this node should be I1 minus I3 plus I2 plus I3. I have minus I3 plus I3. So I'm left with I1 plus I2. Obviously, if you look at node A we have I flowing to node A, and I is equals to I1 plus I2. So that here also I will have I flowing from node D down to the source. Now let's pick our equations. From this circuit, I have three unknowns. I have three unknown currents. So I should expect I'll have how many equations? Three equations. Now let's pick these three equations. The first thing I want us to do is to pick each of the loops. The first loop I want us to look at is the loop A, B, C, A. Now loop A starts from A, it runs to B, to C, and back to A. Now let's draw that diagram. So it looks like this. This is loop. Please permit my diagram. Yes, okay, there's a resistor here, the 300 ohms resistor. Here's my 300 ohms. Here I have an 100 ohm resistor, and here I have a 500 ohm resistor. So that this is A, B, and C. Now I should be able to, and on from A to B, what I have here is I1. From A to C, what I have here is I2. And from B to C, what I have on this line is what? I3. So that obviously using our voltage law, we'll be saying that minus 100 I1 minus 300 I3 plus 500 I2 is equals to 0. So I have this, they are all in terms of 100. I can divide through by 100 to make it less clumsy. So I'll be having minus I1 minus 3 I3 plus 5 I2 is equals to 0. Let's call this equation 1. Now let's pick our second loop. For my second loop, I'll like my second loop to take the node from D to B to C and back to D. So that my second loop is taking D to B to C and back to D. This is the loop. I have simply redrawn the loop. Now so that if I take this part, this is my D, B, and C and back to D. Now taking it from B to C, I'll be taking minus 300 into I3 minus 100 into I2 plus I3, and here will be minus or plus. This will be plus 500 into I1 minus I3 equals 0. So this is minus 300 I3 minus 100 I2 minus 100 I3 plus 500 I1 minus 500 I3 is equals to 0. Now let's rearrange our equation. I'll have 500 I1. For the I2s, I have minus 100 I2 minus 100 I2, and for the I3, I have 300 minus 300 minus 100, that's minus 400, minus 500, that's minus 900, minus 900 I3 equals 0. So that's 5I1 minus I2 minus 9I3 equals 0. Now let's take the last loop. Considering loop EABD, I can say that from E, I have 100 volts minus I will flow through as 100 I minus 100 I1. So from loop from the node A, I have I1 flowing from node A minus 500 I1 minus I3 is equals to 0. Now let's remember that my I is the same thing as I1 plus I2. So that this becomes 100 minus 100 I'll have I1 plus I2 minus 100 I1 minus 500 I1 minus I3 equals 0. Now conclusively, we can say that this will be 100 minus 100 I1. Now, I have 100 I1 minus 100 I2 minus 100 I1 minus 500 I1 plus 500 I3 equals 0. Let's collect like terms. We're saying that 100 minus, here I have 100 I1, 100 I1 and minus 500 I1. That becomes minus 700 I1. And for the I2, I have just 100 I2 and plus 500 I3 equals 0. Now, so that I have 100 will be equals to this 700 I1 plus 100 I2 minus 500 I3. Let's rearrange for convenience and divide all through by 100. Now this becomes 7 I1 plus I2 minus 500 I3 will be equals to 1. So we have divided by 100 all through, so this is just 5, not 500. Now let's call this our equation 3. This becomes our equation 3. Now I want to solve for the equations, but I want to create more space. Let's pick my equations one after the other. Here I have equation 1. Here also I have my equation 2. And here I have my equation 3. Now here I have my equation 1, 2, and 3. I've easily just drawn them out. I want to use the Gaussian elimination method to solve this simultaneous equation. In case you missed our lesson on Gaussian elimination method, please don't hesitate to check the description below. We'll place a link to that lesson. So that this becomes, let's break it down first into their various matrices. Now, I'll write the matrix out. This is minus 1, 5, minus 3, 5, minus 1, minus 9, 7, 1, here will be minus 5. Then, obviously, to be my I1, I2, I3, and is equals to 0, 0, 1. Now, to solve for Gaussian elimination method, we need to introduce my augmented matrix minus 1, 5, minus 3. This will be 5, minus 1 again, not 9, sorry, this is minus 1, minus 9, yes, 7, 1, yes, minus 5, and I introduce my augmented matrix 0, 0, 1. Now, the first thing we want to eliminate this item here. We want to eliminate this first column and the second row, the item on that. So we'll multiply this by 5. This is minus 1. Minus 1 times 5 becomes minus 5. Plus 5 will becomes 0. And eliminating that item, I'll be saying this is minus 1, 5, minus 3. Yes, 0. So this item automatically becomes 0. Then on the next item, we'll be multiplying the same 5 again by 5. That will be 5 times 5. 5 times 5, which is equals to 25. Now we'll add this 25 to minus 1 to become 24. To become 24. The next item will be 3 minus 3 times 5, which is equals to minus 15. Minus 15 now plus minus 9. That becomes minus 24 again. It is minus 24. The last item next item we want to eliminate the 7. This 7 here, which falls on the first column and the third row. To eliminate 7, we'll be multiplying the first row by 7. 7 times minus 1 becomes minus 7 plus 7, that's 0. So this becomes 0. The next item is the 5. 5 times 5, that's 35. 35 plus 1, that's equals to 36. So this is 36. And the next item will be 5, will be 3 here. 3 times 7, that will be minus 21. Minus 21 minus 5, that will be minus 26. Yes, minus 26. Then we still have 0. 0 times 7, that's 0. 7 times 0, that's 0, plus 1. Here I'll have 1. Obviously, I'll have 1. Then I can close my augmented matrix. Here I still have 0. I can close my augmented matrix. Now, to eliminate this 36, 36 now is in the second row. We'll be using 36 is in the third row and the second column. we'll be using 36 and 24. To eliminate 36, I'll multiply 24, I'll multiply 24 by 36 over 24 and subtract from 36. Okay, now let me just pick other items first. This is minus 1, 5, minus 3, and here is 0. Here is 0, 24, minus 24, 0. Now, since I'm eliminating 36, obviously this will become 0. I've used 24 multiplied by 36 over 24 to eliminate 36. Now we'll do the same thing again to 26. Look at it this way. It's going to become I have minus 24 into 36 over 24. Here's 1, here's 1. This also become minus 36. Now, but we're not going to, this is minus 36. Remember, we're subtracting minus 36 now from minus 26. So the arithmetic is going to look like this. It's going to become minus 26 minus minus 36. That will become minus 26 plus 36. Obviously, that's 10. So I have 10 here. Then here is 0 times whatever thing you multiply 0 by becomes 0 plus 1. I say I have my 1 retained. And with this, we've come up with our augmented matrix. We've come up with our augmented matrix. Here is 10, not we had 10 here. Now, so that since I have my augmented matrix this way, here is my I1, this is the column for I2, this is the column for I3. So from the third row, we can say that 10 I3 is equals to 1, which implies that I3 obviously is equals to 1 over 10 amps. If I3 is equals to 1 over 10 amps, in my row 2, I have that 24 I2 minus 24 I3 is equals to 0. So that 24 I2 is equals to 24 I3. Let's create more space. Now we said 24 I2 is equals to 24 I3. We know that I3 already, we've gotten I3 to be equals to 1 over 10. So that I can easily substitute that this is 24 I1 will be equals to this 24 I2, sorry, will be the same thing as 24 into 1 over 10. So that I2 now obviously is equals to 24 into 1 over 10 times 1 over 24. 24 cancels 24. I2 also is equals to 1 over 10 amps. Now, if I2 is equals to 1 over 10 amps, then what is I1? Now, we have that minus I1 from row 1 plus 5 I2 minus 3 I3 is equals to 0. Let's substitute for I2 and I3. Minus I1 plus 5 into 1 over 10 minus 3 into 1 over 10 is equals to 0. 5 here is 1, 5 here is 2. Minus I1 plus 1 over 2 minus 3 over 10 is equals to 0. Obviously, I1 is equals to 1 over 2 minus 3 over 10. Let's pick an LCM here. This is 10. Here becomes 5 minus 3, which is equals to 2 over 10. 2 here is 1, 2 here is 5, which is equals to 1 over 5. Now, I1 is equals to 1 all over 5 amps. Now we've seen this, we've been able to deduce our various values for current. With this, we'll be able to deduce the various values for each of the currents. I hope you understand one, how to use Kirchhoff's law to solve for currents and voltages, and also how to use Gaussian elimination method to solve complex equations. Thank you for staying with us and see you in our next class.